Okay, can you hear me again? Hopefully that's working now. Sorry about that. Something screwed up. I have a million tabs open. Fix that. Let's close some of these. I'll re-upload it. That's all good. It'll all still be there. Just do that. Right, so what I want to go over is these here. Okay, so unless there's any other questions about the assignment before that. Now, these you're using in the assignment. There's one other I'm going to add there. So this is obviously setting, this is clearing, this is toggling, and this is testing. Now this is testing if there's a 1. If we want to test if there's a 0, we put not, and that, so that's testing if it's a 0. Okay, so if setting if it, checking if it's set, checking if it's cleared is another way to put that. And so does them all them operations make sense to you? Or do I need to explain more? All right, cool. So I'm going to have a look at these and see how they operate because they're really important for the assignment and for the exam. So I just want to check that I've the link on LMS. So I have, cool. Well, that's good. All right. So here we're setting a bit, clearing a bit, toggling a bit, testing a bit with it set, and this with it cleared. So we add the not to test if it's cleared. All right. So, or not set is the other way to think about that. So let's go up a bit and let's look at the setting first. Now, this isn't a C operation. This is just that we've set this up in a way that it will set a bit. Okay. So let's create a variable called, I'm going to use cars because they're nice and short. I'm going to set binary 11101110. Okay. So that's the binary number, and I'm going to go A, and I want to set bit. So before we start, this is bit 0, 1, 2, 3, 4, 5, 6, 7. And let's say I want to set bit 4. Now, if I set one of these ones that are already set, but nothing's going to change. And that's another thing that you need to be aware of. Okay. So what I want to have a look at is what does this actually do? So let's have a look. we want our A. So we have A. Now, this is a compound statement, meaning we saw that plus equals becomes assignment plus something, where O goes here, and then N goes here. Okay, so the compound statement here is the same thing. So we actually have A becomes A ored with 1 shifted 4 places. Now, we're going to have a look at this operation first because it has a higher precedence and also it's in brackets. So when we look at this, we have a 1 here, which in binary is 0, 0, 0, 0, 0, 0, 0, 1. This shift operator will move the bits around such that they're moved this amount of places. The direction of this shift operator sets which way it's going to shift. So let's just do a quick example. If I have 0B, 0, 1, 1, 0, 1, 1, actually, let's just make this simpler. Let's go 0, 0, 0, 1, 1, 0, 0, 0. And I shift it this way 2 places, then this becomes 0, 0, 0, 0, 0, 1, 1, 0. Okay? And if I shift this 2 places to the left, then we end up with our original value. Now, if I shift it too far, we'll actually lose values, which is just what happens. That's okay. So here we're shifting this 1 4 places. So moving it 1 place moves it here, moving it 2 places moves it here, moving it 3 places moves it here, moving it 4 places moves it here. So we end up with 0, 0, 0, 1, 0, 0, 0, 0. Now we used macros in our assignment. So this bit here meant something. Okay? So we can choose to set bit 4, or that might be error bit or something like that. Does that make sense so far? Is there anything that you're unclear of at this stage? We're all still there. Can you still hear me? Can you hear me? We'll get to that. We're not up to that yet. Calm down. So we all understand the shift part. Okay, so if you had an exam question that is something like A equals, int A is 0x 1, 4 in hex, you should be able to, let's say we have int B equals A shifted 2 places. You should be able to say what is in B. Okay? And to do that, convert this to binary, do this operation, and then convert it back to hex. If, let's say, it gets printed out in hex. %x B. Okay? So you should be able to do something like this. Quite a simple example. But you're better off converting this hexadecimal number into binary, then doing this, then converting it back to hex to print out the result. Okay, and we've been through binary hex conversions quite a few times. And this is why. So it helps us do stuff like this. Yep. We're happy with that. All right, now we're going to look at this binary OR thing. Now, all of these operators were a full week of content, so, I know, half a week of content. So you need to know this. It's quite a significant part of the exam. So we're now going to look at this OR. Now we have our variables here, 1, 1, 1, 0, 1, 1, 1, 0. And we're going to do a binary OR between those. So this here is a binary OR. This here is a conditional OR. Okay. Now both of these work very differently. We've seen how the conditional OR works. It will return a 0 or 1, depending on if both conditions are, if either of the conditions are not 0, or they're both not 0. However, the binary OR works very differently. So the binary OR looks at every bit, okay, and compares them, and does pretty much what the conditional OR does, but at the binary level, so at the bit level. So this OR operator is going to look at these two first, okay? And it's going to OR them. And so a binary OR, a 0 and a 0 gives a 0, a 0 and a 1 gives a 1, a 1 and a 0 gives a 1, and a 1 and a 1 gives a 1. So looking at both of these, we get a 0. We then go on to the next two. We have a 1 and a 0, so we get a 1. We have a 0 and a 1, so we get a 1. We have a 0 and a 1, we get a 1. We have a 1 and a 0, so we get a 1. We have a 1 and a 0, a 1 and a 0, we have a 1 and a 0. And so our resulting value is this, and that gets stored in A, so we get 1, 1, 1, 1, 1, 1, 0. So if we have take a look at that, so if that's bit 7, 6, 5, 4, 3, 2, 1, 0, we see we've successfully set bit 4. Okay, and we can do that. So if we get a question in the exam, also it's something like int A equals 0x and 2, we have int B equals 0x for 8, and we have int C equals 0x. Sorry. A or B. No, there's no reference notes. You'll get the precedence, and that's it. And then printf percent D, not D, X, sorry. And you'll get C. Okay. So the only thing you'll get in the exam as a reference is the precedence, which looks something like, okay, wrong. lost my YouTube's. There it is. So does that make sense to everyone in terms of the binary? So I'll just quickly mention another question we got asked. So you'll get something like that for the exam. It's not this one, but something similar. And that's I'm pretty sure the only reference you get given to you in the exam. I'll have to double check that. That's what I remember from last I looked. Okay. So no, you won't have any more reference in that. And you won't be able to take your own reference in. Alright. Alright. So do we want to go through the other ones, or do you think you've got them? Or is there something else you'd like to cover? Or is there a question? No, you can't. You'll get kicked out of the university. Yes, so the reference gives the order of operations. Alright. So do you want to go over another example for, let's say, clearing a bit? Clearing is actually probably the most interesting one. The testing is quite easy once you've got this as well. Do you want to go over that, or do you want to go over some exam questions, or do you want to go over something else? Not getting much feedback yet. No, so the practice exams we're going to try run as realistically as possible. However, we are going to go over the answers after we do them so that you'll get to know what you did wrong and right. We want you to understand what you do and don't know. So you won't have notes for both of them. We're going to try and run it realistically so you understand firstly, how an exam runs at La Trobe, because most of you, it'll be your first time. So we're going to try and run it realistically. And so, no, you won't have notes. So you should study before you come to the practice exam if you want to get the most out of it. Thank you. Right. Is there any other questions about the exam or the assignment? I am going to try and hold another live stream for the exam, before the exam. I haven't decided when. How many hours depends on pretty much your engagement. So what we'd like to do, I'm leaving this up to you. Exams, assignment stuff. I think we've covered the assignment to death a bit. What day what? So let me just get this up. So this is how the exam sessions are going to work. You arrive at 10. The exam goes from, I don't know. The day and time for the exam prep live streams. As I said, I will try and run. I most likely will do it, but I'll probably try and do it closer to the exam because that's when you get the most attendance. Last year I ran about 20 or more hours, but I found that no one showed up until the last one. And then I had like 30 people at the last one, so I probably won't do that. I might just hold one big one. I think we had a like 7-hour stream for the last one last year. So I might do something similar. If that sounds good. So the exam prep sessions, that's how it will run. Okay, but yeah, it all comes down to your contribution in helping me out by answering questions and asking questions. Right. What would we like to cover? I'm not going to dictate what you want to cover. What is that? Why is that open? So there's a couple of things that you should do to study for this exam. So the quiz questions are really excellent for studying for the exam because this is last year's types of questions. There'll be a new one of these out, but it's very similar. So there'll be multi-choice questions. There will be outputs from programs and code fragments. These are similar to the quiz except for you actually write the answer, but you've seen in the quiz, these are the kind of questions that you get. So the quiz is really excellent for these two. Okay. Showing the memory state using box and pointer diagrams. I would recommend going back through your labs and your assignments and trying to draw out the box and pointer diagrams to get practice with this. And also the quiz questions, using them to draw out the box and pointer diagrams. Okay. The other thing you can do with the box and pointer diagrams is that I've got a whole heap of practice programs here. So you can open these up. Okay. So you can open these up and try and draw the box and pointer diagrams as the program progresses. Okay? And there's a heap of them there. If you do all of these, you're pretty much prepared for the box and pointer diagram part. Okay? So that's why these are here, and I might actually generate some more. The code that I used to generate these was kind of rushed, so I might do that again, do them a little better. Okay, so that's the next thing I would practice. Identifying errors and interpreting diagnostic messages. So this one comes into reading the lecture notes. So each week there's a reading material, and that's where you will have a written answer that you will explain what something like this is. Okay. So for example, in function main, error and valid type argument of universe star have each. Okay. A flow diagram. Now there should be stuff written here, but there's not. So either reading a flow diagram or drawing a flow diagram will be one of the questions. And then a complete program. So the flow diagram one, I recommend just going through your labs and drawing out the flow diagrams for everything. Or using lectures or quizzes to draw that. And then we have a complete program. Now, this is a difficult one to prepare for, but if you go back to your earlier labs or any of your labs and start trying to write them out by hand, I might, if I find time, give you guys some practice questions, but this is about understanding the code and being able to solve a problem. So have a look at a stage in your assignment and see if you can just write it out by hand or in a lab. It's not going to be massive, it's not going to be like the labs, but it won't have the steps like the labs do. It'll just be a problem statement, and then you have to write the solution. Now the other one here is CSE 5, so if you're doing masters, there's another question, and you're given a program and you have to describe what the program does, and then there'll be points pointed to in the program and you have to explain what they mean. Okay. Now, in the exams, I've also got this Lab 12, which I do want to go over sometime, because last year we didn't have the spare week. So what I might do is find some spare time and go over this. I really could have done this today. Maybe we could do some of these. These are really good questions. The box and pointer diagram, one here on Lab 12, is really good for this. So you can see how the box and pointer diagram would be given in the exam. And then you have the quiz questions. So you can access these quiz questions and attempt them as many times as you like. And that's all there for you. These ones will be available tomorrow. All right, so you can try as many quiz questions as you like. There's also some extra quiz questions there from 2015 if you want to try them out. Okay. So there's heaps of quiz questions there, and you can practice them. You can use box and pointer diagrams on them, and I've given you heaps of time. And so you can access all the quiz questions. They are still random, but you get more questions and more time, so you just keep clicking through until you get the ones you like. And anything else I think of that will be handy, I will just keep chucking on the exam tab. So I've also chucked these flowcharts and box and pointer diagrams in here. There's also the answers for these here, which will come up next week. So yeah, is there any other questions relating to that? So yeah, anything useful I'll keep chucking up there as I go. So to study compiler errors, you need to read the lecture notes. It doesn't specifically give you the compiler errors, but if you understand the lecture notes, you should understand what it's talking about. So, yeah, understanding that is really important. Okay, is there any other questions, problems, issues, or assignment questions, etc., etc.? Because I'm happy to go over anything, but I want you to bring it up. All be done. No more questions regarding the assignment or exam? Or do you want to do some practice? I need some feedback. What would you like to do? So, no, because I'm not getting much. So, Aaron, if you've got more assignment questions, list them. More exam topics. So let's just list the topics. And okay, just list the 251. No, I think it's too short. Okay, we can do this stuff. I'll just let everyone answer. All answer. That would be great. So, pause that for a sec. Alright, so who's still here? Just say hi if you're here and you're staying around, because what I might do is go over some of these questions in the video that I had up before. Not you. Well, that's last year. Okay, cool. Right, so I'm going to get up some questions. And these are really good questions that I developed last year for practice with the exam. So we'll go through these one by one. So, and I keep stressing this quite a lot. But make this a bit bigger. It's to be readable. So let's get some questions going. We can go through them. So, first question. Put the first following numbers to a binary. Now, we saw this in the last help session. We've seen it in many of the help sessions. Oh, dang it. That's great. RGB. So, convert the following hexadecimal numbers to binary. So, let's just do the first one. So, as I've said before, when you get into the exam, you may want to draw up the table. And a lot of you have worked out that there's a pattern here. So you can use your pattern if you like, but you still should understand that we are going up by ones. Okay, so if we go all the way, oops, did I make a mistake? Yes, I did. So even I can make a mistake. So we can make this table and go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And so you can do this in your exam. And we can quickly get the answer. So here we have 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 1. What about this second one? Can we do that? So have a go at that. You've got your table there. So just write down your answer. If you don't know the answer, just say don't know. Alright, so everyone pretty much got that. So 0 is just zeros. And then we get a 0, 0, 0, 1. Now, you don't need to put spaces. You can put the spaces if you like. It makes it a bit more readable if you do. So we want A, oops, B, C, and D. Okay. So what about going the other way? We have this. So let's just put these over the top. So how would we go converting these? We'll get on to some final questions. I've lost my questions. Where the hell did I put my questions? There. So what answers have we got? So let's do this one first. Yep, 5 and 2. Sounds right. And what about this one? One, yep. And what about this one? Okay, so you got AD 55. Now, I'm going to extend this question. What if I put a 1 here? So now it's 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1. What does this become if I put a 1 at the start? If you don't know, just say don't know. So it just does still work. So if I have the number 165 in base 10, okay, so the base that we're normal. If I had a 0 in front of it, it still is the same number. If I had another 0 in front of it, it's still the same number. Now, we know that we still have to read it from this way. So if I had a 1 in front of 165, I've just added a 1 to the next set of units. So here, and a mistake that a lot of people make is they try and read the number from this way. So we're adding a 1 to the start. So the smallest digit is still a 5. The next digit is still a 5. The next digit is still a D. The next digit is still an A. And so we can just chuck a couple of zeros in front and we get a 1 here. With any number, we can just chuck zeros in front of it. It doesn't change the number. Okay, does that make sense? So now I'm going to list another question. Is anyone else still watching? There's quite a few people watching, but not many people answering. So if you're watching, you might as well answer. All right. So next question. List the function names and library for the following. So I'll give you a couple of minutes for that. So hopefully everyone that's watching can do that. So I think the question said the function's name and library. So there's 2 for all of them. Have we got any more answers? So there should be 7 people. Yes. If you've got an answer, please listen. Sorry, I'll change keyboards. Got 2 keyboards there, I always forget to separate. Use this keyboard. I always forget about that. So Alright, so let's go over these. So prints formatted data to the console. So that's printf, print formatted, and that uses standard input-output library. Okay. Opens a file, so that would be fopen, and that is also a standard input and output. Used to compare two strings, we have string compare, which is part of the string library. Used to read a formatted string from a file would be fscanf. Okay, and that would be from the standard IO. Now this last one's a trick question. We know the size of operator, but this is actually not part of any library, it's part of standard C. Okay. So it's not part of any of the libraries. All right. So our functions are printf, fopen, string compare, fscanf, and size of, which isn't part of the library. All right, next question. Show how you would declare in code a struct with the tag name dog and has member variables name and age, where name is a string of 80 characters and age is an int. Okay, so we got some solutions, and they're close, but they're a little bit wrong. So we have struct dog. We have either order. It doesn't really make a difference. Name 80 and int age. Now, when declaring a struct, we also need a semicolon at the end. And all of you forgot that. Dun, dun, dun. All right, so don't forget that. You do need a semicolon at the end, and someone picked that up right at the end. Good work. All right, nice, quick, easy question. Give your answers as quickly as you can. Go. Yes, death. Let's get a couple more answers, and we will reveal. Okay. So what size in bytes is storage type car? It's 1 byte. Now, 1 byte equals 8 bits. Okay. So just be aware of that as well. Someone had the right answer and they added something to make it wrong. All right, next question. One byte is 8 bits, not 4 bits. Oh, why is everyone saying that? Okay, what is wrong with this? What's wrong? If you don't know, just say don't know. Okay, so it's this equals sign. Okay, so what it's actually going to do when it gets through the pre-compiler stage is it's going to printf pi equals %f slash n equals, and you'll get a compile error. Okay, so we don't want to print equals. We want to print 3.14. So there shouldn't be an equals here. All right. Okay, next question. Leave my room. Sorry. Okay, so we have 3 here. Yeah, yeah. So give it a go. Oh, awesome question coming up. Alright, I think most people have got this. It's a born person mode, etc. What we got? Now we can call this whatever we like. So I'm just going to call it A. Double B 5. And we can go 1.2, 4.5, 3.1, 6.2, 18.777, semicolon. And now we're going to do pointers to ints. So int star A6. Okay. So I think most people got that. Alright. Question that catches everyone out on the exam. What does this print? Cool. I think most people got that that's 0 fairly quickly because we have the integer division. Okay, so we print out 0. Alright. You don't see the switch case very often, so this is actually a pretty good question. What is output by these? So we have one answer. we get some more answers? Any more answers? We'll change in our mind over and over again. Okay, so the answer is cricket, football, end of list. And someone had the right answer, but then they doubted themselves. So with case statements, the variable here, 1, will be replaced, and it will take the case. So we'll start here. Now, unless we have a break, it will just continue down until it finishes. So we end up with cricket, football, and end of list. Okay. So usually you'll see case statements with lots of breaks in them, unless they're intentionally set up so that they flow through. Okay. All right. Now we get to the fun one. All right. So we just went over some of these bitwise stuff. So see how you go. If you don't understand, just say you don't understand and we can quickly get to the solution. These are all still here as well. Not quite a few people watching. So if you can all try and answer the questions. Good. Yeah, the whole exam's bitwise. The questions are written in bitwise operations. Right, so I think most people struggle with this. So let's just go over it. Move that over. So first thing I'm going to do is just convert everything down to binary, just because it makes it easier with bitwise. Okay, so we've got one guess for 3. Let's see if they're right, because I don't actually know what the answer is yet. So I'm going to convert everything down to binary, just because it will make things a lot easier when we get to the end. So the 3 I know is going to be 0, 0, 0, 0, 0, 0, 1, 1. I'm going to convert this down to binary, and we get 0, 0, 0, 0, 0, 0, 0, 1. That one's the same there, and a 2 we know is 0, 0, 0, 0, 1, 0. Okay. So they're the only conversions. They're very quick and easy ones. And 0 is obviously 0. So if you're ever working with bitwise, if we're ever getting with, if we get a question with bitwise and we get X, it's a good idea to convert everything to binary and then convert it back if you need to. All right, so we've got bit test, which is currently 0, 0, 0, 0, 0, 0, 1, 1. And we're going to go bit test and equals not 0x 0, 1. Now, we can see that we're overriding. We're not overriding. We're have bit test becomes bit test and not 0, 0, 0, 0, 0, 0, 0, 1. Okay. So if we have a look at this, the not flips this upside down, so we end up with 1, 1, 1, 1, 1, 1, 1, 1, 0. We have 0, 0, 0, 0, 0, 0, 1, 1. Now, when we add, they both have to be 1 and 0. So we can see that the only thing that changes is from this is that first one becomes a 0. Okay, so we end up with 4 zeros and 0, 0, 1, 0. So we can see that this is a clear operation. Right. I'm not answering that. All right. So we've got that currently. So now I'm going to go to this if here. So I've got 0, 0, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 0, 0, 0, 0, 1. Yeah, so they cleared the first bit. Yeah, so they cleared the first bit. So you're right, but you just need to specify which bit they're clearing. So it's that very first bit. Okay. And this here would be the same as having 1 shifted 0 places. Okay. Right. So now we have this AND here, and we can see already that none of these line up such that there'd be a 1 and a 1. So this comes out as a 0. 0, 0, 0, 0, 0, 0, 0. So we can see that this is true. They're both equal. So we know that we're going to be in here. So we can already cancel out that 3 guess because, sorry, it appears we're going into here, all right, because they're equal. So now we do another test, and this time it's bit test, which is this one, against 1, 0. And if we add this together, we can see that we end up zero, 0, 0, 0, 0, 1, 0. Okay, and that doesn't equal 0, so we print 2. So with these questions, as I said, try and convert everything to binary. It'll make it a lot easier. And if you draw them out, just remember, whenever that you're using bitwise, you're comparing the individual bits with each other. Okay. All right. All right. All right. All right. That's perfect. Okay. We might finish up with this one. This is actually a pretty good question to practice for the exam. It's a fairly difficult one, but I have seen things like this in the exams in the past. Generally, there is a couple of very hard questions on the exam, just because there's a huge amount of variation. The order of operations, you'll get the order of operations on the exam. No, the answer was 2, it's not 3. You were wrong. Lag. I can't do anything about lag. Yeah, I know you said 2. I remember that clearly. All right. Have a go at that one for a little bit. Get through that. I think we'll finish after that. Okay, no, it's not as simple as that. So let's have a look at this question. It is simple. It is pretty simple. C's doesn't have that many operations. There's only like 50 keywords, so there's only really 50 things you can do. No, I'm not lying. I obviously, programming can get difficult, but it's actually generally the logic that's harder than the programming, because the programming is just a language. So the difficulty with programming is solving the problem. It's at this stage you're mostly learning language, which is the easier part, but solving the problem or expressing yourself is the difficult part. Yes, this one is pretty difficult. All right. So we have an input here, which is A, B, C, A, D, A, G, B, J. Then we have number 4 equals 0. Now, if you remember from our arrays, if we have a 0 here, it's just going to fill the whole array with zeros. So we have num, and it's full of zeros. Okay. Then we have count, which is also a 0. And we have while count is less than 10. Obviously, 0 is less than 10. We then have car, ch becomes getCar. So getCar grabs the first character from the buffer, and we have an A in there, and it's the character A. Now, we then have, if the character is greater or equal to A, and character is less than or equal to D, then we do this, else we break. So if we have a look at this, we have character which is A, and that's equal to this, and it's less than D. So it's going to go into this condition. All right. Then we have this. So we have num ch minus A. And this might seem very, very odd. But remember that an ASCII character is still just a number. It's just a binary number in memory. So if we look at the decimal equivalent, this is 65, and we have 65 here because this is an A. Okay, so A in ASCII. I've lost the chart again. There it is. Okay, so how is it less than D? So in ASCII, D is 68, A is 65, so 65 is less than D. Okay, so when you look at the ASCII table, let me grab an ASCII table up. It's a bit small. So if we have a look at the ASCII table, the letters go down. So we've got 65, 66, 67, 68, 69, 70, 71, 72, 73, and so on. So all the capitals are basically here. Now you'll notice that the lower cases are here. So it means that all lower cases are larger than upper cases in terms of their value. No, the ASCII table is not provided in the exam. You need to understand simple things like this. Like you don't actually need to know the number, but that's about it, really. I think I'll have to double check that. But no, I don't believe the ASCII table will be provided in the exam. Okay. But you don't need the ASCII table to solve this question. Okay. I know that these are uppercase. I know A is a value. It could be any value, but as long as I give it the same value as this, it doesn't really matter. I could say A is 100 minus 100. I know that the alphabet counts up by ones. So A is 65, B is 66, C is 67, D is 68. So we have num0 plus plus. So this is incrementing. So this becomes A1. All right. Then we go down here and we go count plus plus. So now count is 1. We go back up because it's a while loop. 1 is less than 10. So we get another A, which happens on that line. It's between this. So A is between this. And then we go A minus A. So we end up with the same thing. So we increment again. We get num is 2. We then go count plus plus. So we get 2 here. 2 is less than 10. So we get a B. So B is between these. And we now have B minus A. Now, we know A comes before B, so they're one number apart. So B minus A has to equal 1. So num1 plus plus. So we now have a 1 in here. We then get down here, count increments to 3. Is 3 less than 10? Yes, it is. So we now grab this C. I probably should have been changing this at the same time. So we grab the C. C is between these two letters. So now we have C minus A. So we now have a 2 in here. We add 1 to 2. And so we get a 1 here. We then add 1 to count. So we get 4. We go back up. 4 is less than 10. We grab the next letter, which is a lowercase a. Okay. Now, is a lowercase a between these two values? No. So it goes to the else part and it breaks from the loop. So we end up at the printf and we print out 2110. And that's the answer. Quick question before we finish. Oh, that's all right. You tune out early, like I'm not the one with the exam. Just one quick question before we finish. Malloc and Gallop, do you know what the difference is? So they're very, very similar, and they're both allocation. So this is memory allocation. This is clear memory allocation. So the only difference between these is that calloc sets everything to zeros, where malloc will just leave it uninitialized. Okay, so losing space. So if I have int star x equals malloc size of int times 2, and I have int star y equals calloc size of int times 2. The difference is purely there is one other thing. So, which I rarely use calloc. So calloc works slightly differently in terms of its arguments, but they do the same thing. So here in memory alloc, you just list how much memory. In calloc, you say how many I want and what size, and there is 2 arguments. Okay. So their prototype is slightly different in terms of what arguments they want. It's the same thing, except for this has 1 argument where you just bunch everything up and just multiply it, where here you have how many you want and then a comma and then the size of what you want. Now the other thing that it does is this sets everything to 0. So if I went printf, let's say %d, and I go x0, versus if I go printf %d y0, this one here could print absolutely anything, okay? Because it hasn't cleared the memory when it's allocated it. Where here, I'm guaranteed that it will print a 0. And that's basically the difference between malloc and calloc. Okay. And that can be handy if you want to clear the memory. If you don't need to clear the memory, then you shouldn't really use it. Does that make sense? I could do the box and pointer diagrams for just the basic one. So here we have 0, 0. X would have question mark, question mark. They both create the same amount of memory. It's just one sets everything to 0 at the start, and it has a slightly different set of arguments. All right, is that all good? All happy? All sad? I will email you back about that problem as well. You're not going to like the solution, but yeah, not much I can do. All right, I'm going to end it there. Unless there's any questions, I'll be on the chat for if you need in the next few minutes. All right, catch up.